Let's welcome our first speaker, MAYRO and Grace WIVELL for their presentation, Perception of Stress in Leo.
Hello. Today we're going to be talking a little bit about an experiment we ran about determining stress or the perception of stress in Leo. We're going to start by talking about some background on Leo. We'll talk about the experimental design. We'll discuss the results. We'll talk about our conclusion and some future directions that we have in mind for our experiment.
Okay, so Leo is spoken in Flores, which is an island in Indonesia. I usually tell folks if you're trying to find us, we're next to the Komodo dragons. And so Leo is spoken in this pale green over here, and it is part of the Central Flores subgroup or dialect chain. And so that starts from Leo, Sika is not included, and goes all the way to Moronga. And so there's several languages, which I have actually on the next slide listed here, that are considered part of the same dialect chain. So again, it's Austronesian, CMP, if you believe in that. But more importantly, the Central Flores subgroup, and important for the creation of this study, just a little bit of information about the words in Leo. So it's highly isolating, so we didn't have to worry about morphology and stuff interfering, which was actually quite nice. And the syllables are mostly CD, and the words are mostly bilingual. And so that was what we were trying to create in this as well. Okay, so previous to Michelle taking on all of the processy things in Leo, it had been claimed that Leo exhibited fixed initial stress. This was based on impressionistic evidence from a small number of speakers in Elias's master thesis. And so to verify this claim, MAYRO, this one, not a different MAYRO, conducted a corpus study, and those results showed that penultimate syllables exhibited increased duration and intensity, which are two of your typical correlates of stress, but we did not see increased F0, which is also sometimes a correlate of stress. So this suggests that stress is not contrastive, but it also may not be fully predictable either. And so in light of this, and also just because we feel quite strongly that you should be supporting your production data with perception data if you can, we designed this perception study to determine whether or not Leo speakers are sensitive to all of this.
So some background literature. So demonstrated that speakers of languages with no stress or very predictable stress patterns exhibit something called stress deafness. This is not real deafness. What it means is insensitivity to stress contrast. So given the minimal pair that are identical for segmental content but differ only in stress position, they have a difficult time discriminating the two words. And this is because they don't have a phonological representation of stress. It's not necessary for the language for determining meaning or discriminating words. This is akin to what has been demonstrated for like speakers of Japanese who have difficulty discriminating English L and R, right? They don't have separate phonemic categories for those two sounds. It's a non-native segmental contrast. They don't need it to speak Japanese. So they have difficulty in laboratory conditions discriminating the two sounds, even for learners of English who speak or native Japanese speakers. But stress deafness exists on a spectrum. It's not binary. You have the speakers of languages that stress is completely unpredictable, contrastive stress languages like Spanish. They predictably don't show any stress deafness. They need it to speak the language, so they don't show any stress deafness effect. On the opposite end of the spectrum, you have completely fixed stress languages or languages that have phrasal or no word stress, phrasal stress like French, completely exceptionless. So standard French at least. Stress is always going to follow on the last syllable of a phrase, even if it's like a function word or something, it's exceptionless. So for these no stress or fixed stress without exceptions languages, those speakers tend to show a very strong stress deafness effect in experimental conditions. And then somewhere in the middle, you have speakers of languages that have fixed stress, but some exceptions, things like Polish, where it's generally penultimate fixed stress, but then you get monosyllabic words, or you get borrowed words from Greek that show slightly different stress patterns, and because they have to store that information, it's suggested that that's the reason why they show kind of an intermediate stress deafness effect, where there's some stress deafness, but not to the extent that you see with no stress language speakers like standard French. And so because Leo seems to be showing fixed stress, but potentially one kind of notable exception to a fixed stress pattern, we wanted to test whether Leo speakers demonstrate a stress deafness effect as well. So following Dupont et al. 1997, we designed an ABX discrimination task. To do this, we created essentially what we're calling stress triplets. So 3 words were kind of concatenated. Word 1, which is A, word 2, B, word 3, X. Each word spoken by a different speaker. We played these consecutively. Word 1 and 2 are completely the same, save for stress location difference. So the same segmental content, differ only in stress position. Word 3, the same as either word 1 or word 2. Speakers were then played all 3 and asked to determine whether word 3 is the same as word 1 or word 2. I have an audio file, an example of this. It didn't seem to work before, but we can try it. It does not work. I will print it. This is one of the real words that we used. It's bebo, bebo, by different speaker. As you can see, it's identical segmental content. So the stress differs between 1 and 2, right? It's initial or penultimate, and then final. And then word 3, you're seeing initial again. So the speaker would be, or the participant of the experiment would be instructed to identify that word 3 is the same as word 1 and not word 2. We also created filler stimuli just to make sure that participants were really engaged with the material. And to do that, we created more triplets, but ones that differed in a segmental contrast, not in a stress contrast. And this contrast is native to Leo. It's a contrast between the prenasalized stop and the angma. So this should have been very salient to speakers as a native contrast in the phonemic inventory. It's the same thing, 3 different speakers, 3 words consecutively. 1 and 2 differ only in that one contrast. In this case, it's that first consonant. And then word 3 is the same as either word 1 or word 2. And again, the audio won't work, but it sounds something like nasa, basa, and basa. Let me. Anyway, I played it for you by reading it aloud. Not quite as good. These words were all taken from a corpus online on Paradisec. It's from Yanti 2019, collected it. We used really kind of 3 CVC general words. One was a real word, that was that bebo I showed you. And then 2 non-words that we spliced together in prot from different words. So we took words, we separated along a syllable boundary, like a stop or something that was easily segmentable, and created naturalistic non-words. For these 3 words, we created 2 words for each word, where we manipulated stress position in those words using p-solo resynthesis. So for each word, there was a penultimate variant, stress variant, and a word final stress variant. And we created that prominence effect in accordance with values that I found in that production study that Grace mentioned. So in the production study, we found that for penultimate syllables, vowels were about 50% longer than the vowels in unstressed syllables in the same word. 3 decibels greater intensity and no real F0 difference between syllables. So that's how we manipulated stimuli for the experiment. And because F0 was not found to correlate with prominence in the production stuff, we didn't want to manipulate that in the same way that we did with duration and intensity. We just left it, we just conformed it to the pattern that we saw in the production data, which is all final vowels were made a little less than a semitone higher in pitch than the penultimate vowel. So that means that ultimately we had 18 tokens, 3 words with 2 stress conditions, right? And then 3 speakers, each speaking the words. And then they organized into those triplets that I showed earlier. Within each trial, we randomized the order of stress placement, so whether word 1 and word 2, which syllable was stressed first, and the speakers, A and B. We used both male and female voices for this experiment, which means that whenever word 3 was always spoken by the unique gender, so that we could avoid participants matching word 3 to whichever word was spoken by another member of the same gender, as opposed to matching along these contrasts that we were looking for, the segmental contrast or the stress contrast. So why ABX design and not something more simple like AX, that same different task, right? And the answer is stress deafness is stress insensitivity. It is not full deafness. It's been shown in experimental trials that even speakers of fully exceptionless fixed stress or no stress languages like French, they can hear stress contrasts given a sufficiently simple task like an AX task. I think Dupont 1997 shows that even in an AX task, French speakers can distinguish that contrast because they're storing it like the knowledge in short-term memory. They're able to draw out those acoustic differences. So we needed a sufficiently difficult task so that participants couldn't just rely on short-term memory storage. They were forced to kind of look, they're forced to demand, like we forced to demand on the memory load and kinetic variability so they could draw on some kind of phonological representation of stress as opposed to some kind of easy, short acoustic shortcut. And we did that by creating the ABX task as opposed to an AX task and introducing those 3 different talkers, so variability in the F0. In the experimental literature, it's really all non-words that are used for the most part. We wanted to also include a real word because they don't really ever justify why these studies use non-words as opposed to real words. I mean, it would seem probably because, to increase the difficulty I discussed, to prevent any kind of recognition effect, right? Maybe they can't really hear the stress contrast, but they know when something sounds off for a language that's native, a word that's native to their language. So we wanted to include both non-words and real words just to see if this was necessary to do. So this is what the participants saw. They were sent a link via WhatsApp to Qualtrics. Here's the website. This is what they were shown. It's all in Indonesian. Most Leo speakers are bilingual in Indonesian. Leo does not have a standardized written form, so we needed to make sure the experiment was in Indonesian. So minimally, participants had to be bilingual in both English or both Leo and Indonesian, not English. Yeah, and then you see this button, Putar Suara, that's play audio. So the participants each had an opportunity to play every single experimental triplet up to 2 times, no more. In the literature, it's pretty much capped at 1. So participants, whether it's an ABX task or some other kind of slightly different stress discrimination design, participants typically only have 1 opportunity to listen and answer, and then they move to the next trial. We wanted to do 2. And the reason for that is if you do it sufficiently, they can do it as many times as they like. They're going to rely on an acoustic strategy, right? It's not real deafness, it's insensitivity. So if you play it over and over again, eventually you'll hear it even if you speak a language with no stress. So they couldn't do it infinitely, but we wanted to give them the opportunity to do it at least twice in case there was an internet connectivity issue or something. This area, sometimes internet can be spotty or at least unreliable. So we wanted to make sure that even if there was some kind of internet connectivity issue, they could hear the audio at least once. And so we coded that in JavaScript with Qualtrics. Before each experimental trial, or before the experimental trials began, there was a training period. They had 5 practice trials where they got feedback. Is word 3 the same as word 1 or word 2? They selected the answer. If it's correct, correct appeared, incorrect appeared for incorrect answers. But this used different stimuli. Same, question type, everything else, but different novel stimuli, both segmental triplets and stress triplets. Overall, the experiment after the training period had 32 randomized trials, 24 of those stress triplets, and 8 of those segmental triplet filler items. Since the production data showed that stress is not contrasted, we found no minimal pairs. We expected participants to be better on identifying that segmental contrast than the stress contrast. That being said, as I mentioned, there was at least one notable exception to the fixed penultimate stress pattern we were seeing. So we predicted that participants with maybe a little above chance, but more or less at chance, they would show some stress deafness effects akin to what those speakers with stress languages, with maybe a few exceptions like Polish, would perform at, as opposed to something like standard French.
Okay, so I basically sent the experiment out via WhatsApp to a couple of contacts. I didn't send it super widely because this is more of a pilot, but I sent it out to a few people and asked if they could take it and maybe share it with some of their friends. So what we're going to discuss today, we have 4 participants, 1 male, 3 female, ages 26 to 39. They were born in 4 different Leo-speaking subdistricts. They are presently living in 3 subdistricts of Indonesia, including 1 person who is actually living outside of Flores. They all spoke Indonesian. 3 of them also spoke English, and 1 of them also spoke Mandarin. They're also highly educated. So 3 of them had their undergraduate degree, and 1 of them actually had their master's degree. So we did have 9 people who left the experiment without completing. And so they completed anywhere between 1 and 76%. So I was like, I want to kind of see what's going on there. So we could maybe hypothesize as to why that might be happening. And so our hypotheses for this, and we're going to actually return to this at the end of the talk, but it could be poor internet connectivity, right? We tried to work around this, but it could still be that. Interestingly, the folks who finished all are highly educated. The folks who did not finish do not have higher education. And so I wonder if there might be some unfamiliarity with this kind of task in the folks who didn't complete the experiment. And so that's something we're trying to consider. And it could just be fatigue, right? That could also just be a reason as well. All of this to say, for today, we're going to be excluding the data from all these, regardless of if there is some data. We're just going to be talking about the completed experiments.
Okay, so results. You see we have our 4 participants here that completed the experiment. In the lighter grayish blue bar, it's their performance, the percentage correct they got the target items, that stress contrast. In the darker bars, the performance on the segmental triplets. As you can see, they all did much better, at least on the filler items and segmental contrast, than the stress contrast. participant 4 in particular got all of the filler items correct and tested about at chance at those stress contrast items. One participant, participant 2, you can see actually tested exactly at chance on the filler items, which was unexpected, right? That tested that native segmental contrast. We really expected them to do pretty well on it, so we were a little surprised by that outcome. We still found that their performance overall fell within 2 standard deviations of the mean, but still less, they performed less well on the filler items than we expected, so we did want to take that into consideration. That being said, they still did better on the filler items than the target items, but didn't perform as well as we expected on the filler items. And so for that reason, we divided here on the left are all participant averages, and on the right, participant averages without participant 2, even though that person did fall within 2 standard deviations of the mean. Actually, just at the cutoff of 1 standard deviation of the mean. So as you can see, for all participants on the target items, they tested exactly a chance, whereas they tested about 70% for the correctly identifying the segmental contrast. But if we exclude participant 2, it's even more notable that we see the bars become even further apart. So they're still testing more or less at chance on the target stress items, but they jump up to 75% accuracy on the segmental contrast, which is pretty good. We also didn't observe any differences for the non-words versus real words, exactly 50% on both token types, so we didn't bother including a bar chart for that. No difference observed. And we also coded to see how many times they clicked the audio button to play it. Remember, they had that maximum of 2 plays they were allotted. We found that they played on average the target items more than the filler items, which is what we kind of expected, right? They would have a harder time hearing the stress contrast, so they played the button more. And that was about 1.33 times for the target items as opposed to 1.28 for the filler items, except for participant 2, who actually is the only participant who played the filler items more than the target items, which makes sense given that they didn't do that well on the filler items. So I think it speaks to some difficulty maybe with potentially understanding the task, or the filler items themselves. So yeah, participants in general tested at chance on the stress contrast and much better at the segmental contrast. And there's no difference in the performance for the real word, WIVELL versus the non-words that we spliced. So it suggests that participants are exhibiting a stress deafness effect that we predicted. They were not particularly great with the right experimental conditions at identifying stress contrast in words that differed only in stress but identical for segmental content. These studies also support the findings of the reduction study. It would have been very surprising if they tested excellently on this. If Leo doesn't have any kind of contrastive stress, it would be quite surprising given the literature on it. So it did support those findings of the reduction study. It was consistent. Moving forward, we want to expand the study. We want more participants and we want more target items. We don't want to increase the total number of trials. Already it was at 32, which seems like a lot. So we're going to increase more tokens or more triplet types, but counterbalance them so that the same participant isn't having the same items over and over again. We think this will help maybe a little bit with fatigue, which is one of those things that we identify as potentially one of the reasons why we're having so many incomplete test results. And in addition to any other changes that might come out of today's discussion that could be helpful in moving the next step forward. We also want to, for an in-person chance to complete this experiment in addition to the online collection. We really like an online collection format. It's convenient for someone who doesn't want to have to, he just wants to click a link and complete it from home or complete it from wherever they have internet connection on their iPhone. But we think it'll also be helpful if a familiar face can offer both, a laptop with a good internet connection or a cell phone with a good internet connection, as well as the chance to answer any questions in the field at the time. We were very careful in how we phrase the directions and the training period to make sure that was clear, but it's always helpful to have someone on hand in case any questions come up. So we think that'll help. It'll also allow us to reach speakers who might not have, because Qualtrics is nice in that it's really smartphone accessible. You don't need a PC for it, but it still doesn't help people who don't have smartphones. So some references. Big thank yous to Faris Bette on the left there. He transcribed a lot of the data that became the tokens for this experiment, as well as Fortune on the right, who both transcribed data and looked over early versions of the experiment and helped us with the Indonesian translations. Great, thank you very much. Any questions?